please welcome Uwe Kubach, Vice President, Internet of Everything, Enablement Products and Innovation at SAP.
Yeah, hello everybody. Also warm welcome from my side here to the IoT stream at this nice event. It's a pleasure for me being here and speaking. So also thank you to the organizers for inviting me. So my talk is on what the IoT means for enterprise applications. And like almost every talk, I think I have to start with some numbers on how many things finally will be connected, and depending on which survey you look into, they differ quite a lot. So I think what is important about is that they continue to increase, and the current predictions for 2020 are significant above what we see for mobile phone adoption today. It's even more than we have toothbrushes, for example, on this planet. And of course, this will also have an impact on the market. We see that, again, depending on the survey you look into, there are numbers stating up to 40 to 50% growth rate of the overall IoT or M2M market, as also sometimes called. This does not only include, of course, software, where my company is active, but this also includes the hardware, the embedded modules, and also, of course, the communication networks, the data traffic that you have and that you can charge for. The question is, why is IoT now such a big topic every there? I think we have similar solutions, telemetry solutions, RFID technology for 10 plus years now. One of the reasons, of course, is that the technology became much cheaper during the last couple of years. But what I think in particular in the business that my company is in is even more important is that the technology became much more mature. So nowadays we can really build mission critical enterprise solution on top of this technology. It's reliable enough, it's available everywhere. If you only think about communication networks, you really have access to a mobile network almost everywhere. It's reliable, you can really build business applications on top of this. And this is, I think, really changed. And so we can now build applications on top of the technology that 10 years back would just not have worked. I think there's a lot of terms flowing around, and people talk about M2M, and in Germany often also talk about cyberphysical systems, and now Internet of Things. How does this all relate? So I think this all started with embedded systems. So you build some modules, some hardware into physical objects, everyday objects, like cars, like refrigerators, whatever. But then there were autonomous systems only built into one physical object, no communication to the outside. The next step was network embedded systems. There are many of these systems were built in the same thing. Again, in a car, you nowadays have, I think, close to hundreds of individual systems, but they are connected with each other, talking with each other, but still within the same physical object. The next step then was really that these embedded modules start communicating with the outside world. At the beginning, this was not done via public internet, but often via certain proprietary technologies. And this is what is typically referred to as machine-to-machine communication. An object, a machine, an embedded module, talks to another machine outside that physical object. So to stay in these automotive examples, this is then a car starts talking to a toll collect system or traffic management systems and the like. And the next step now with the Internet of Things is that many of these systems start talking to each other via public internet technology. It's not private technology and it's not one-to-one anymore, but all these systems start getting interconnected in this Internet of Things. So if an electric vehicle, for example, is driving through a smart city in the future, it will be connected, of course, with the traffic system, but it will also be connected with information from its utilities providers to find the next charging spot that is available and that has a certain tariff. So many systems start talking to each other, and that is the big step forward with the Internet of Things. And this is also what you see here. I think on the left-hand side, this is a little bit what we did in the last 10 years maybe, we connected certain types of assets to certain application. For example, there was, of course, technology to connect a container to a container tracking application, or a truck to a fleet management application. So, but we were somehow on the left-hand side here of this slide, that this all worked fine, often with proprietary technology, but it became difficult if you want to have information from different applications. For example, to make sure that the container arrives in time to be picked up by a truck, right? Then you have to go to the fleet management application, and you have to go to container tracking management application. You have to do quite expensive application-to-application integration. With the Internet of Things, everything now being based at least on the communication layers on the same Internet protocol standards, we can potentially connect all these device categories to one, and this term is also quite new, device cloud, so that you connect all this information coming in from these different categories of assets, of devices, in one device cloud. So first you collect the data in the cloud, and then you can access all this information uniformly from the whole bunch of applications that you build on top of this cloud infrastructure. That's a very, very big advantage. Of course, it's still ongoing research and development work to find the right data models that are not too generic, that they become meaningless, but they are also not too specific, that they exclude certain categories of devices. So this is, of course, a challenge, but let's assume we can solve this challenge. Then you get a kind of data integration for free. And of course, they can therefore much simpler build these integrated applications that access information from various information sources, not only from one specific device category. And on the second-hand side, of course, second advantage that you get is that all the functionality that you need over and over again in these applications, like the device management, or the onboarding of the devices, certain application services, security, you only have to implement it once in a horizontal platform, and all the applications can, of course, use this in a uniformly manner. This is the advantage of every horizontal platform, so to say. What do we get from this transformation into this Internet of Things? Of course, I think the main reason why we are doing this is real-time transparency. So we really know what is going on in the real world. We do not longer work on estimations or on planning data, but really on real data. So I can ask a system, or I can access the physical world like an information system. So I can ask how many people are in this room today, how many people are on the highway at a certain point in time, and I get back real-time information, not estimations, not planning data, but really information from the physical world. And of course, one of the high things is that this will lead to completely new business models. Having this transparency, I can charge my customer, for example, on how they use a machine that I sell them, or that I even only lease them in the future. And so I can charge them, for example, for the hours of operations. We talked to one customer who is producing compressors, and they do not sell the compressors anymore, but they sell cubic meters of compressed air, including all the service for the machine, of course, also the compressor, the machine itself. But this is how the business model changes. Sometimes it's a little bit overstressed with these new business models from my personal perception, because people tend to forget that also the technology has a big potential already to optimize existing business processes. So for example, talking again about service and maintenance of assets, of course, having this transparency of how a machine is used, how many hours of operations I have, I can, of course, offer my customers far more detailed service plans, for example, than just sending every 6 months a service technician there, not knowing what is really going on with the machine. So also with these existing business processes, there's a big potential to improve them and to use this technology. And often this is a lower entry barrier. If you start using this new technology, we recommend people sometimes start to focus on one existing business process, and in a second step, think about these new business models. Of course, then the technology also has a huge potential in what we call horizontal integration. If we share this information, or the companies involved in such a device cloud are willing to share that information across their company borders, then of course you have a huge potential to give insights to many companies, for example, within the supply chain of what is going on with the suppliers and so on in real time again. This is what we call horizontal integration. The next step is all the vertical integration. So we do not only have separate software layers in manufacturing, for example, they have the automation layer, the manufacturing execution layer, and then on top the applications. But now you can really directly access from the applications the shop floor, the information on the shop floor, the sensors on the shop floor. So this is sometimes what we call sensor to action. So we do not only collect data anymore and analyze it and then maybe have some insights, but we even can then trigger some action and immediately, for example, start a service order if we observe that something is going wrong with a certain asset or machine. The nice thing about the applications is that the IoT applications, they all follow more or less the same pattern. They monitor something with all the sensors that are out there. They then analyze this data, even make predictions more and more often. And then I think what is the nice thing, if you have also the business applications behind, that you can optimize and act on these insights and trigger real actions in the real world in real time. So you see here a bunch of applications where we are active. So logistics, of course, is a very big topic because you have all the transparency where your suppliers are, where the trucks are, where containers are, and so on. The next thing is in manufacturing, for example, you have all the machines, the assets connected. I mentioned already these examples about remote service management, going even a step further and making predictions about when something will happen with a certain machine. These are all topics that are coming up now and where we already have the first solutions in the market, and there people really start taking this up. It's not that we only talk about future, it's really already happening now. Same in connected building, be it private homes, be it professional buildings, managing the energy consumption, see where energy is wasted, and so on and so forth. This is all happening now. Connected vehicles are also a big topic. I mentioned fleet management, but also the electric vehicle management, finding charging spots, reserving them. This is all already happening. More from, because we're in the technology track, if we look on these applications more from a technology perspective, they all share the same key requirements. And it's also, I think, an argument why we see so many device cloud platforms emerging at this point in time. So they all cover a huge variety in terms of scale. So we do not only talk always about the hundreds, thousands of devices connected to one application, but there are also very valid applications if you talk about high-value industrial assets where you only connect hundreds or thousands. But those individual assets then might have 200 sensors built in and produce 40 megabytes of data per machine per day. On the other hand, there are scenarios like in the smart vending, for example, where you connect vending machines to applications to optimize the replenishment process, for example. But there you might have 50,000 of these vending machines, but each of them only producing one text message per day, sending the fill levels of the machine. So with this variety and heterogeneity, we have to deal if we talk about IoT platforms. Definitely. Next thing we have to deal with is distribution. So typically these scenarios are widely distributed, globally distributed across different IT infrastructures. So if a company wants to provide a service for its assets that it sells to its worldwide customers, these assets, of course, are operated typically in each of them in a different IT infrastructure. So we also have to deal with connecting things in different IT infrastructures. And finally, of course, everything deals with connectivity, and we have to support again, a huge variety of connection paradigms, be it reliable, be it best effort, but also different communication networks, mobile networks, fixed networks. We see them all, right? So if you want to have an IoT platform, you have to cover all this variety. This is typically where the stack are. The message I want to make there is I think the world here is so complex, and we talk here about digital transformation. I think part of this digital transformation is that we will not see any company dealing such a big stack on its own, but that there will be networks, ecosystems that have to work together to make these end-to-end scenarios happen, right? I think in the speech after me, you see, for example, a company that is focused here on the lower layers, and of course we partner with these companies like Cisco to make an end-to-end experience for our customers possible, because they won't want to talk to a telco provider if they have a problem with the connectivity. They don't want to talk to the hardware provider if they think it could be a hardware problem, or to the software vendor if they think it might be a software vendor, but they want to have one person or one contact that is responsible for the end-to-end solution, expect that he is the right partner to offer an end-to-end solution. What we also see when we really make real projects happen, I talked already, the business models. Often, if we talk to smaller companies, for example, they're still not fully sure about how they want to do their business model. How do they want to charge, right? Do they charge for compressed air, or do they charge still for the asset? So this is often a thing that has to be solved as you start a new project. The legal frameworks are sometimes challenging, right? Because you are operating new environments. You sell maybe a machine with software on it, and the software is then operated not in your own premises, but somewhere else. What is about liabilities and guarantees and all that? If you collect the data, who owns the data? The one who produces it, the one that collects it, the one that sells the machine that produces the data. So there are even no regulations for that as of today. So everything has to be covered in individual contracts about who is owning the data at this point in time, right? Also, regulations for data privacy are becoming more and more important. I think for sometimes in Europe, this was really a competitive disadvantage that we have strict regulations on data privacy. But as part of this digital transformation, we see this coming even a competitive advantage, because our customers, for example, take very much care about what happens with their data, and they're very happy if there are strict regulations on how this data has to be dealt and how it can be stored and where it is allowed to be stored and so on. I talked already about the technology piece quite a lot, so I can skip that here. Last point I wanted to mention is operations. I already indicated in our project, it's very important for our customers that they get an end-to-end support. That's really a key success criteria. They do not want to have a zoo of partners plugging some solution together for them, and if they have a problem, a finger pointing starts. No, they really want to have an end-to-end solution, as I said, from the sensor to the action, and only have one single point of contact who takes responsibility for all the questions that might come up, all the problems that might come up, and solves these problems with its partners. Security is, of course, also a very big topic. It comes to operation and daily operations. There, I think the key is not that the technology is not there, but it has to be the right technology for the use case. Of course, you can do today hardware encrypted VPN tunnels to high value industrial assets. There, the business case is typically there, right? That you can have, I don't know, a couple of euros per year to manage such a connection to such a high value asset. But if you talk about a humidity sensor in a vineyard that only costs €1, then of course you cannot afford to connect that with a hardware encrypted VPN tunnel, but then you have to have the right security solution in place. So it's not the technology challenge, but it's more the right technology for the individual business case that you are facing. Having said that, I would like to thank you for your attention. I'm already a few minutes over time. I'm here for the whole day. If you have questions, feel free to contact me during the day. Thanks for your attention.